Have you ever wondered if our ultimate leap into the cosmos comes with a hidden, heavy price?
What often gets framed as a fun science fiction adventure is actually a brutal wall of harsh physics and unforgiving biology. We are talking about humanity's impending voyage to the Red Planet. You have undoubtedly caught those flashy news alerts and audacious pledges to plant boots on Martian soil within the next 10 to 20 years.
Private companies boast about their upcoming launches, while space agencies map out intricate step-by-step schedules. Nations all across the globe are eagerly throwing their hats into the interplanetary ring.
Society treats this monumental leap as merely the next box to check off.
Almost as if we are repeating Apollo 11, just with a slightly extended road trip through the dark.
Yet, hidden under that mountain of enthusiasm and aggressive planning lies a chilling reality nobody wants to discuss. The pioneers who depart for that rusty world are almost certainly saying a final farewell to Earth. And it is not because of crashing rockets or broken gear.
The true culprit is gravity, wresting a spacecraft free from the Martian surface and keeping a crew alive for the grueling trek backward turns a return flight into a mathematical nightmare. By the time this journey ends, you will grasp exactly why these exploration voyages are, in truth, permanent settlement campaigns. You will see why those trailblazers pressing their boots into the red dust must bid our pale blue dot an eternal farewell. This is not doomsaying or dark fiction, but the cold, undeniable certainty of navigating our cosmic neighborhood. Before we launch further into the void, if unraveling the secrets of the cosmos sparks your imagination as much as it does ours, please hit that like button and subscribe. That tiny gesture fuels our mission to bring these starry wonders to fellow stargazers everywhere. Let us dive right in. Why do we constantly gaze at Mars as our ultimate destination beyond our home world? For starters, it is practically sitting in our cosmic backyard, orbiting as the fourth rock from our star. It is our immediate planetary neighbor in the vastness of the solar system. When our paths perfectly align, that rusty sphere drifts to within roughly 34 million miles of us. Imagine two runners on a circular track catching up to each other on the same side of the sun, achieving a perfect celestial alignment, known to astronomers as opposition. However, when our orbits swing us to completely opposite ends of the solar track, that gap balloons to a staggering 250 million miles. Yet, even at its most distant, reaching this neighbor is a mere hop compared to targeting anything else in the starry abyss. The second planet from the Sun might seem like a logical backup plan. Unfortunately, Venus is an absolute inferno, where the air would effortlessly flatten a titanium submarine, and the ground heat could turn solid lead into puddles. Looking further out into the darkness, we encounter the colossal realms of Jupiter and Saturn. But those gargantuan gas worlds sit thousands of times further away and offer absolutely no solid ground for a spacecraft to touch. That leaves our red neighbor as the sole reachable sphere where an astronaut might actually walk on rock, where the climate can sometimes nudge past the freezing mark, where frozen oceans hide beneath the dirt, and where a single solar rotation clocks in at nearly 24 hours. It holds the crown for the most Earth-like environment we know of, though that is an incredibly low bar to clear. Picture an endlessly frozen wasteland wrapped in a carbon dioxide blanket that is merely 1/100th the density of our own sky. In this desolate realm, the baseline climate hovers around a bone-chilling minus 80 degrees Fahrenheit, and there is zero magnetic shielding to block out lethal solar radiation. Massive gales of rust-colored dust can swallow the entire globe for seasons at a time. Still, when you put it next to a crushing Venusian hell or a bottomless Jupiter storm, that frozen desert looks like an inviting oasis. This unique glimmer of hope is precisely why the planet has bewitched humanity for generations. Back in the late 1800s, a stargazer named Percival Lowell peered through his lenses and swore he spotted sprawling aqueducts carving up the alien terrain. He envisioned these as desperate irrigation ditches,
engineered by a highly evolved alien race trying to save their rapidly drying homeworld from extinction. But what if the greatest discoveries of our cosmos were built on a complete illusion? The truth is, his observations were fundamentally flawed. Those supposed waterways crisscrossing the surface were nothing but a trick of the light. Yet the spark of imagination had already ignited a wildfire. Almost overnight, our dusty neighbor transformed into the ultimate extraterrestrial playground, filled with legendary alien beings in the public consciousness, serving as the grand cinematic backdrop for epic tales of dying empires and hostile cosmic conquerors. H.G. Wells terrified readers with his chilling vision of a merciless extraterrestrial invasion, while Edgar Rice Burroughs transported earthly heroes to a harsh desert landscape fractured by endless tribal warfare. Then came Ray Bradbury, whose haunting chronicles imagined brave pioneers carrying humanity's hopes and flaws across the void, inevitably clashing with an untamed frontier. This deep-rooted obsession with the Crimson Sphere only deepened as time marched on. As humanity finally slipped the surly bonds of gravity during the space race of the 1950s and 1960s, setting our sights on the Martian surface felt like the undeniable next step. After all, if we could conquer the 240,000-mile void to our lunar companion, wouldn't crossing the solar system be the exact same game, just on a grander scale? Consider how Apollo successfully delivered 12 brave souls to the lunar dust between 1969 and 1972. Those historic voyages demanded a mere 3-day sprint each way. Our explorers danced in the low gravity for no more than 72 hours before catching a ride back. From ignition to ocean splashdown, the whole adventure wrapped up in roughly 8 to 12 days. Make no mistake, it was a terrifyingly complex and perilous undertaking, draining an astronomical fortune from the treasury. Yet it was entirely within our grasp. The space agency absolutely shattered doubts, proving flesh and blood could endure the cosmos, operate in a dead zone, and plummet back to our blue marble in one piece. With those lunar footprints secured, the world collectively held its breath, expecting an immediate Martian sequel. We possessed the blueprints, and our raw ingenuity had been battle-tested. Surely unlocking the next planetary door just required welding larger rocket boosters, packing a heavier lunchbox, and writing fatter checks. During the 1970s and 1980s, visionaries sketched out audacious plans featuring atomic engines and colossal Saturn V-style launch vehicles. The foundational logic behind these dreams? This red dirt expedition would simply mirror our lunar triumphs, blast off from our homeworld, cruise through the endless dark, touch down, poke around the craters for a bit, then fire the ascent engines and coast back to safety. It sounded incredibly straightforward on paper. Yet as the brightest minds crunched the brutal numbers, a terrifying reality began to emerge from the equations. Reaching this new frontier shares absolutely zero DNA with a moonshot. The staggering gulf of space, the relentless ticking clock, the absurd mountains of propellant, and the devastating biological cost. Every solitary puzzle piece multiplies the danger to an unimaginable degree. What masqueraded as a mere upgrade of past glories was actually an entirely new, terrifying beast of physics. Picture the sheer vastness of space. That is hurdle number one. Even though our planetary neighbor sits right next door on a galactic map, to a fragile human, the gap is mind-numbing. Our moon is a comfortable 240,000 miles away, whereas the red planet, even at its absolute closest approach, hides 34 million miles in the distance. That translates to a journey 142 times longer than our longest trip, stretching to over 1,000 times farther when the orbits swing wide. This cavernous emptiness breeds nightmarish logistical hurdles that lunar crews never had to face. Navigating the celestial seas to reach that dusty sphere eats up 6 to 9 months, dictated entirely by orbital mechanics and planetary alignment. Let that sink in for a moment. That isn't a 6 to 9 month round trip. That is half a year or more just to reach the front door. The brave pioneers of the past were completely detached from humanity for a maximum of 12 days. Future voyagers heading outward will be locked in a flying tin can for at least 6 months before they even glimpse their destination. Half a year confined within a claustrophobic metal shell no bigger than a walk-in closet, inhaling scrubbed oxygen, sipping purified sweat, and surviving strictly on dehydrated rations. 6 solid months absorbing relentless solar storms and deep space radiation, stripped entirely of the comforting magnetic shield our homeworld provides. 180 days floating weightlessly, watching helplessly as the skeleton turns to chalk and muscles waste away, no matter how intensely they train. Have you ever imagined battling 6 agonizing months of pure psychological strain, locked inside a tiny metal box while helplessly watching our pale blue dot shrink into the endless abyss? Yet that is merely the first leg of the voyage. And right here is exactly where the harsh laws of astrophysics step in. Touching down on the red dust does not mean you can simply flip a U-turn and head back, as celestial choreography strictly forbids it. Think of our solar system as a colossal racetrack. Our home world zips around the sun in exactly 365 days, while our rust-colored neighbor plods along, taking 687 days to finish a single lap. Consequently, this cosmic dance keeps the two worlds in a perpetual state of shifting alignments. To jump between these moving targets without running dry, we rely on a magical alignment, a perfect geometrical sweet spot for an energy-saving trajectory that swings our way just once every 26 months. Naturally, the exact same mathematical hurdle applies when you are on the alien surface. The ticket back only aligns once every 26 months. However, there is a brutal catch hidden in the calendar. Your celestial doorway home does not magically unlock the second you land. Since you rode in on one specific alignment across the void, the universe forces you to sit tight until the subsequent cycle aligns again. In practical terms, you are marooned on an alien world for roughly 2 whole years, just waiting for orbital physics to give you a green light. Imagine surviving 730 days in a hostile wasteland, especially when the longest lunar camping trip during the Apollo era lasted a mere 3 days. Add it all up, and the absolute shortest timeline for a round trip to the Red Planet stretches to 3 massive years. You spend 6 to 9 months coasting through the dark, endure a 2-year layover in the dust, and then face another 6 to 9 month trek homeward. 3 entire years. And that assumes an absolutely flawless expedition. That implies 0 mechanical hiccups and firing the return thrusters on the exact planned second. Missing that razor-thin departure window by even a fraction means you are stranded for an extra 26 months, forced to wait out the next planetary alignment. Giving away 3 years of human life to deep space is a staggering gamble, a monumental risk where the physiological decay could leave a crew so battered that surviving the trek back becomes a medical nightmare. And speaking of technology, let us dive into the propellant problem, because this is the exact moment the cosmic math turns absolutely merciless. Every single vessel that has ever punched through our atmosphere is chained by a universal law known as the Tchaikovsky rocket equation, penned by a brilliant Russian visionary back in 1897. This formula dictates the delicate balance of a spacecraft's weight, its combustible reserves, and its ultimate speed limit, using a concept that is both elegantly simple and entirely punishing. Pushing a ship faster requires burning more gas, yet gas itself is incredibly heavy. Packing extra propellant balloons the overall weight of your vessel, meaning your bulkier ship now demands a significantly larger explosion to push that newly added mass. Naturally, that extra liquid fire piles on even more weight, requiring an endlessly expanding reservoir of thrust. It becomes a vicious, exponential cycle. Squeezing out just a tiny bit more speed forces engineers to strap gargantuan, towering silos of explosives onto the launch pad. Journeying to our moon masked this nightmare. simply because our silvery neighbor possesses a remarkably weak gravitational pull and lacks an atmospheric blanket. The tiny lander that danced across the lunar plains only had to hit roughly 5,400 feet per second to break free, float into orbit, and reconnect with the mothership for the long ride back. Hauling enough combustible liquid to manage that specific hop was definitely a challenge, but totally within human capability. That spindly lunar craft hauled roughly 5,500 pounds of propellant to touch down and another 5,000 pounds to blast back into the sky, fully loaded and dripping with fuel. The whole contraption tipped the scales at about 33,000 pounds. But gazing out toward the red planet reveals a completely different beast. A mysterious world that pulls you down with nearly 38% of our home planet's gravity, forcing us to completely rethink how we explore the deeper wonders of our solar system. Sure, stepping onto the red planet won't feel nearly as heavy as standing on our home world, but the pull is certainly nothing to ignore. Imagine jumping on the lunar surface. Now cut that freedom in half because Martian gravity pulls you down about twice as hard. Because of this stronger grip, breaking free from its invisible hold demands a vastly greater burst of speed than merely hopping off the moon. To just barely scrape into orbit, any ship blasting off from those rusty sands must accelerate to roughly 11,800 feet per second. We are talking well over twice the sheer speed needed to leave our silvery companion behind. Now, here is where the unforgiving mathematics of spaceflight kicks in. Needing twice the speed does not simply mean packing twice the gas. Instead, the demand skyrockets out of control, multiplying upon itself. Think about the sheer scale of the math for a moment. Picture a vessel about the size of the classic Apollo lunar lander, and imagine trying to launch it from the Martian dirt up into the vacuum. You would suddenly find yourself needing roughly 4 times the propellant that the original moonwalkers burned through. That translates to a staggering 20,000 pounds of explosive liquid merely to lift off and park in orbit. Yet the journey is far from over, because you still have to break out of that parking orbit and chart a course across the void back to humanity. Pushing entirely away from the planet's gravitational well means hitting an escape speed of nearly 11,800 feet per second relative to the world you are leaving. And once you finally spot the pale blue dot, you cannot just slam into it. You need thrusters to hit the brakes. Whether you plan to smoothly glide into orbit or dive straight through our protective atmosphere, slowing down costs serious energy. Tally up every single burn, and the sheer volume of propellant required to get a crew home is absolutely mind-boggling. While aerospace engineers debate the exact blueprints, even the most optimistic math reveals you would need anywhere from 80,000 to 150,000 pounds of propellant exclusively for the flight back. We are talking about a gargantuan, almost unbelievable payload of combustible liquids. But here lies the ultimate cosmic trap. There are no gas stations in the void. Every single drop required for the trip home must first be hoisted out of our own world's deep gravity well, dragged across millions of miles of empty space, and gently touched down onto the dusty alien plains. So what happens when the brightest minds at space agencies and independent aerospace firms crunch the numbers for a two-way crewed voyage? They wind up sketching out ships so impossibly massive, they sound like pure science fiction. Imagine trying to assemble an armada weighing several hundred tons while floating in orbit, long before anyone even set sail for the stars. To put that mammoth scale into perspective, think back to the historic moon missions where the entire multi-part vessel, from the crew cabin to the lander, tipped the scales at roughly 100,000 pounds, or 50 tons, while circling our globe. A round trip to our neighboring planet demands at least 5 to 10 times that sheer bulk, if not vastly more. Trying to heave that much dead weight off the launch pad means we would either need a relentless fleet of heavy rockets or an entirely new, monstrously powerful class of launch vehicle that remains on the drawing board today. While the physics say such a feat is within the realm of possibility, the financial toll would be absolutely astronomical. When accountants forecast the budget for just one fully equipped crewed expedition there and back, the price tags swing wildly from $100 billion to $500 billion, heavily dictated by whatever futuristic tech we are forced to invent along the way. That is essentially matching the economic weight of the whole lunar landing era, corrected for modern money. And remember, those legendary moonwalks represented the single most monumental and costly civilian initiative the nation had ever funded. Have we doomed ourselves to never leaving? Not if we embrace a brilliant concept known as in situ resource utilization, or living off the land. The beauty of this concept lies in its magnificent simplicity. Rather than dragging every ounce of your return fuel across the solar system, you simply brew it right there using the alien environment. You see, the red planet is wrapped in a wispy blanket of air that is 95% carbon dioxide. Beneath that rusty surface lies an abundance of frozen water. Robotic explorers have already proven it is there. So by unleashing a clever chemical trick called the Sabatier reaction, we could easily mix that atmospheric gas with hydrogen to synthesize pure methane propellant and life-sustaining water. Have you ever wondered how we could possibly fuel a return trip from another planet? The secret lies in a surprisingly common gas: methane, the ultimate deep space propellant. Picture zapping ordinary water with pure sunlight, splitting it apart at the molecular level to harvest precious hydrogen and life-giving oxygen. That extracted oxygen becomes the vital spark needed to ignite our ship's engines, while the leftover hydrogen gets funneled right back into a brilliant chemical dance called the Sabatier reaction, brewing up even more of that precious methane. Imagine a perfect, endless circle of chemistry. A cosmic gas station conjuring massive fuel reserves out of thin air, using nothing but the red planet's native carbon dioxide, hidden pockets of ancient frozen water, and the relentless power radiating from our sun. This exact vision is the beating heart behind the design of SpaceX's towering Starship. It chugs a specific cocktail of methane and liquid oxygen precisely because we can, in theory, cook up that exact recipe right there on the alien surface. Elon Musk constantly reminds us that harvesting local resources, a concept known as in situ resource utilization, is the only way to avoid bankrupting our cosmic ambitions. If we had to drag every single drop of propellant all the way from Earth just to guarantee a ride home, the sheer financial burden would instantly crush any dreams of interplanetary colonization. On paper, this sounds like a brilliant, foolproof hack to conquer the solar system. Out in the brutal reality of space, however, living off the land brings a terrifying web of mechanical nightmares and life or death gambles. Step one is a logistical nightmare. We have to successfully drop a fully automated chemical refinery onto another world long before human boots ever touch the dust. Think of it like a sprawling, delicate factory that weighs a ton, yet must operate flawlessly. It has to endure a violent, fiery plunge through the atmosphere, unpack itself perfectly upon landing, and hum along non-stop for a minimum of 2 years, all while being battered by vicious planet-wide dust storms. Add in a relentless bombardment of cosmic rays and wild temperature drops swinging from a freezing -100 to a balmy positive 70 degrees Fahrenheit. This robotic factory has to chew through alien dirt, deploying heavy drills to wring out hidden moisture from the parched ground. Then, it must inhale the incredibly frail alien sky, forcing that whisper-thin air through massive mechanical lungs to squeeze out the carbon. Running all this heavy machinery requires a staggering ocean of electricity, meaning we would need to unfurl gigantic fields of solar arrays or drag a literal nuclear reactor across the cosmos. And it must silently churn out thousands upon thousands of pounds of explosive propellant without a single mechanic around to oil a gear or tighten a bolt. So what happens if this delicate robotic ecosystem coughs and splutters? Whether a single valve fails, or the output drips too slowly, or a speck of alien dirt taints the chemical soup, our brave pioneers are permanently trapped. with absolutely no plan B. You cannot just overnight a replacement part from Houston. The nearest hardware store is a 6 to 9 month voyage across the void. By the time Mission Control figures out the glitch and hurls a care package across the stars, entire years will have slipped away. Those astronauts will either have to engineer a miracle using pure willpower and scrap metal, or they will take their final breaths on a desolate rock. Furthermore, this kind of cosmic alchemy takes immense patience. You cannot just flip a switch and fill up the tank. Even if the machinery sings perfectly, brewing up the 80,000 to 150,000 pounds of required propellant drags on for agonizing months, or perhaps even stretches beyond an entire Earth year. Because of this glacial pace, our robotic refinery must boot up the exact second it touches down, ages before any human leaves Earth orbit. Space full years ahead of the launch pad countdown, grinding away relentlessly until the astronauts finally finish their expedition. Stretch and the final, most terrifying mystery of all, but unleashing an uncrewed factory on a hostile world to brew. The absolute pioneers stepping onto that red soil will be playing a cosmic game of roulette, gambling their very existence on unproven local manufacturing. Should that gamble fail, they will become permanent ghosts among the craters of the deep frontier. Suppose Mission Control scrambled a relief ship the exact second an anomaly flashed on their screens. Those stranded explorers would still be waiting 6 to 9 months just to see the rescue vessel approach. In reality, engineering and deploying a deep space extraction fleet would demand several years of grueling preparation. By the time that cavalry finally crossed the cosmic void, the isolated pioneers would have perished long ago. This sheer isolation completely rewrites the rulebook compared to our past leaps into the cosmos. During the Apollo era, lunar explorers could hit the panic button and coast back to the safety of our home planet in just a matter of days. Today, crews orbiting on the International Space Station can dive back into our atmosphere and touch down in mere hours using standby capsules. But for those braving the red sands of Mars, there is no emergency exit. The moment those engines ignite, their fate is sealed. If their resource-generating technology breaks down, they are marooned indefinitely. A glitch in the oxygen scrubbers? It is fatal. A breach in the habitat walls? Also fatal. Out there in the dark, they have no safety nets, no alternate strategies, and absolutely no ticket back, except for the fragile machinery they packed for the ride. But before we even reach that distant world, we need to unravel a far more personal mystery. What does the immense emptiness of space actually do to human anatomy? Unlocking this biological puzzle reveals what might genuinely be the ultimate barrier to ever coming back alive. The cosmos is violently incompatible with our delicate organic forms, posing threats that are almost impossible to exaggerate. Think of our blue marble as a custom-built sanctuary. Its gravitational pull, the rich air we breathe, and its protective magnetic shield are flawlessly tuned to our exact biological blueprint, simply because this is the crucible where we were forged. And every single network inside you, from your pumping heart to your supporting skeleton, down to the immune defenses, the lenses in your eyes, your internal gyroscope, and the tiny microscopic factories patching up damaged cells, was meticulously sculpted over millions of years by the unique physical forces of our home world. Strip away that familiar earthly cradle, and the human machine begins a frighteningly rapid collapse. Decades of orbiting laboratories have given us a front-row seat to this disturbing reality. Voyagers living aboard the International Space Station begin to suffer undeniable bodily decay after spending just a couple of weeks floating weightless. Their skeletal structure starts dissolving, vanishing at a staggering pace of roughly 1 to 2% every single month. This alarming vanishing act happens because our skeletons are highly dynamic, living networks that constantly remodel themselves whenever they are challenged by physical strain. Picture taking a jog on a sunny afternoon. That downward pull forces your legs to absorb impacts, and your biological systems answer that challenge by fortifying your structural framework. Up in the void, that vital pressure vanishes completely, tricking your system into believing those sturdy pillars are now useless dead weight, prompting it to actively dismantle them. The precious minerals anchoring your skeleton are flushed straight into your blood and eventually expelled as bodily waste. After a half-year stint among the stars, crew members routinely shed anywhere from 10 to 15% of their total bone mass. To put that cosmic decay into perspective, it perfectly mirrors severe skeletal deterioration seen in aging patients suffering from advanced osteoporosis. The remaining framework turns terrifyingly fragile, transforming every minor bump into a potentially shattered limb, followed by a grueling rehabilitation that spans years. In fact, a fraction of that lost structural integrity stays gone forever, no matter how long they spend recovering back under Earth's gravity. The withering away of muscle tissue tells an equally grim story. Robbed of the invisible, heavy blanket of gravity to push against, our powerful muscles deflate with shocking speed. Deep space travelers can watch up to 20% of their strength vanish during a 6-month voyage, even if they sweat through brutal daily workouts. Make no mistake, the orbital gym routines are absolutely punishing. The crew battles through 2.5 hours of heavy lifting and intense aerobic exertion every single day. Yet all that sweat merely slows down the inevitable wasting process. The changes inside the chest cavity might be harder to spot, but they are just as alarming. Down here on the ground, your heart acts like a powerful hydraulic pump, fighting gravity to blast oxygen-rich blood all the way up into your brain. Floating in the blackness, that uphill battle disappears, causing the heart muscle to grow lazy and morph from a strong, muscular oval into a weak, floppy sphere. Consequently, the internal hydraulic pressure plummets dramatically. Imagine your heart as a neglected engine. Without the constant resistance of gravity, your entire cardiovascular network basically forgets how to do its job. The moment these space travelers touch back down on solid ground after months in orbit, they are hit with a brutal condition called orthostatic intolerance, which in plain English means the room spins violently and they risk blacking out just by trying to stand up. It happens because your inner plumbing is out of practice. Your heart has completely lost the ability to pump blood uphill against Earth's relentless downward pull. In fact, we have seen crew members pass out cold the second they try to walk out of their landing capsule. For the vast majority of explorers, it takes weeks of agonizing physical therapy just to walk around and live like a normal human again. But it is not just the heart. Astonishingly, roughly 60% of deep space voyagers suffer from bizarre, sight-altering optical issues. Scientists are still unraveling exactly why this happens, though the prime suspect is the absolute weightlessness of the environment itself. Without Earth's downward tug keeping fluids in your legs, your body becomes like a squeezed water balloon, rushing all that liquid straight up into your head. All of that extra liquid builds up an intense, crushing pressure inside the skull, literally squishing the eyeballs out of their normal shape and dangerously swelling the optic nerves. Tragically, for a handful of these brave pioneers, their eyesight has never fully recovered, leaving them with permanent damage long after returning home. Then, there is your body's natural armor. In the void of space, your immune system essentially goes to sleep. Research proves that the white blood cells defending you become incredibly sluggish and confused when floating in microgravity. This creates a terrifying window for sleeping threats. Viruses that have been hiding quietly inside you for years, such as the strains responsible for chickenpox or cold sores, to suddenly wake up and attack while you are millions of miles from a hospital. A simple scratch takes much longer to close up, making the chances of a life-threatening infection skyrocket. To make matters worse, we are finding alarming proof that cosmic radiation, a cosmic hazard we will dive into shortly, shuts down those bodily defenses even further. So, picture this brutal combination: dissolving bones, shrinking muscles, a heart that forgets how to beat against gravity, failing eyesight, and a broken immune shield. And now, stretch that nightmare out over 3 full years instead of a standard 6-month stay. For a hypothetical journey to the Red Planet, a crew would float in absolute weightlessness for 6 to 9 agonizing months, just getting there. Then, they would spend 2 entire years stranded in the alien pull of Mars, an environment with only 38% of the gravity we feel at home, followed by another 6 to 9 months floating back to Earth. Have you ever wondered what that unfathomable timeline would actually do to a living human skeleton? While drifting through the dark void for those 18 months to 2 years in transit, your skeleton dissolves away at a rate of 1 to 2% every single month, resulting in a staggering 20 to 30% total bone loss over 18 months. A prime, peak condition astronaut is suddenly transformed into someone with the brittle, glass-like skeleton of an 80-year-old. The most basic, everyday human actions, just sliding out of a bunk or taking a few steps across the habitat, could literally snap their legs in half. Now, feeling the slight pull on the Martian surface is certainly an upgrade from floating in absolute zero gravity. Yet scientists are still completely in the dark about whether a meager 38% gravity is actually strong enough to halt that skeletal decay. The terrifying truth is, humanity has absolutely zero data on how our bodies react to partial gravity over long, isolating periods. Every single medical record we possess comes from either full gravity here on Earth or the absolute weightlessness aboard the International Space Station. That Martian tug might act as a brake on bone deterioration, but it could just as easily do nothing at all. It is entirely possible that 38% simply is not enough physical stress to signal the body to keep its bones dense and strong, meaning our pioneers would literally be melting away their structural foundations every single day they explore the rust-colored dirt. Should that nightmare scenario be true, when the planetary alignment finally allows them to head home after 2 years, the crew would have bones so perilously thin that merely strapping into the rocket for launch could be a death sentence. And that brings us to the most brutal part of the trip. Punching back through Earth's atmosphere is an incredibly violent, bone-rattling ordeal. The returning capsule must slam the brakes, dropping from a mind-bending orbital velocity of around 17,500 miles per hour down to a standstill in just minutes. Despite the most advanced heat shields and massive parachutes engineering can provide, the returning Voyagers are crushed into their seats by the immense, suffocating weight of multiple gravitational forces. After 3 brutal years of muscle wasting and skeletal dissolving, is there any chance a human body could endure that crushing arrival without shattering completely? Even if they somehow survive the fiery plummet through the atmosphere, what happens when they finally step out of the capsule? Today's space station crews require months of agonizing physical rehabilitation after just a 6-month stint to rebuild their lost strength. Imagine the unimaginable toll of a multi-year interplanetary voyage. Have you ever wondered what happens to our fragile biology after a grueling 3-year voyage to the Red Planet? Rebuilding that shattered health wouldn't just be a temporary hurdle. It could demand a grueling, lifelong struggle. Think of your skeleton slowly turning into brittle chalk. That critical loss of structural density might forever haunt you, never returning to its robust, earthly state. The simple, joyful act of taking a walk through a park could become an unattainable fantasy for our bravest explorers. But an even deeper mystery awaits us. Can our biological systems even remember how to fight against the crushing pull of our home world? After drifting like a feather in the whispering lightness of the cosmic void for so incredibly long, we are staring into a total unknown here, simply because no explorer has ever spent 3 years untethered from our planet's gravitational anchor. There is a terrifying hidden threshold out there in the dark. Your biological programming might rewrite itself to perfectly match the weightless void, making a return to the heavy embrace of our planet absolutely impossible. Picture your heart trying to pump water straight up a steep cliff. it simply might lose the sheer power needed to push blood upward against that invisible, crushing weight. Your skeletal frame could easily snap beneath your own mass, crumbling like dry twigs under a massive boulder. Your muscles, once powerful and athletic, might turn to absolute jelly, rendering you completely powerless to move a single inch. You would essentially become a helpless prisoner, locked away inside the very flesh and blood that carried you across the stars. It is a chilling paradox to consider. Picture a scenario where you perfectly harvest Martian resources to power up your ship, and your sleek metallic vessel operates flawlessly, purring like a masterclass of engineering. Yet despite all those mechanical triumphs, your own organic machinery rejects the very concept of coming home alive. You would touch down on your beloved blue marble, only to realize your ultimate sanctuary has transformed into a hostile, crushing wasteland. And yet, gravity is just one monster lurking in the dark. Let us talk about the invisible fire of the cosmos. This silent killer might be the most terrifying danger of them all. Right now, as you listen to this, you are huddled safely behind two massive planetary force fields. First, an immense magnetic bubble acts like a deflector shield, bouncing away the high-speed electric bullets fired by our sun, and guarding us against the relentless, violent storms of interstellar energy tearing through the galaxy. Second, our thick blanket of breathable air acts like a giant invisible sponge, soaking up any lethal energy that manages to slip past that first wall. Working in perfect, harmonious tandem, these twin guardians tame the deadly cosmic wrath into a gentle, harmless whisper. Down here on the surface, an ordinary person absorbs just about 0.3 rem of radioactive energy every single year from natural surroundings. We call this an everyday background hum of energy, which trickles down from the tiny fraction of starlight slipping through the clouds, and even seeps up from the ground beneath our feet, the stones we build our cities with, and the very atomic makeup of our own cells. But what happens when we climb up into the orbital laboratory we call the International Space Station? Even up there, floating inside our planet's magnetic cocoon, that floating outpost still cowers behind the shadow of our massive world, shielding the crew from the void below. Yet those brave souls still soak up 15 to 20 rem annually, a staggering 50 to 60 times more intense than what we face on the grass outside. Just spending half a year orbiting our skies blasts a human with roughly 7 to 10 rem in total. Space agencies view this invisible barrage as a gamble worth taking in the name of discovery. It nudges up the chances of long-term illness, but not drastically. However, cast your gaze outward to the red planet, where those comforting force fields simply do not exist. Where there is zero magnetic bubble to bounce away the stellar fury, no comforting sky to absorb the blow, leaving absolutely nothing between your fragile DNA and the universe's wrath, except a thin layer of manufactured metal. That metallic skin is practically paper against cosmic rays, unless you build it incredibly dense and heavy. But heavy armor requires massive amounts of propellant to move, trapping us right back in the relentless, unforgiving math of rocket science. So, our best ship blueprints offer a tiny bit of cover, but it is nowhere near enough to dial that lethal cosmic storm down to a survivable breeze. Just cruising through the empty void for 6 to 9 months toward that rusty world would bathe the crew in an intense 30 to 40 rem of pure, unadulterated radioactive energy. And once they plant their boots in that alien dust for a 2-year stay, huddling beneath a wispy, practically useless sky, and completely devoid of any magnetic armor, the angry outbursts from our sun would bombard them with another 40 to 60 rem, depending entirely on the star's unpredictable temper. Add another 30 to 40 rem for the terrifying ride home, and suddenly, A 3-year interplanetary saga floods a human body with an apocalyptic 100 to 140 rem of radiation. That astronomical figure towers incredibly far beyond any, completely shattering the absolute safety boundaries our space agencies establish for a lifetime of exploration. While these strict biological thresholds are carefully tailored according to a person's age and biological sex, the absolute ceiling usually hovers around 100 to 200 rem to keep the staggering odds of cellular mutation in check. A solitary expedition to the Red Planet would instantly devour every last drop of that lifetime safety buffer. Yet, surprisingly, the danger multiplies exponentially when our local star decides to throw a fiery temper tantrum. Every now and then, the sun violently ejects massive waves of invisible energetic bullets, a phenomenon scientists call solar particle events. Imagine standing in a torrential downpour of invisible energy that completely floods a spacecraft in mere moments. If a colossal stellar eruption catches a crew off guard halfway to our planetary neighbor, the explorers could absorb several hundred rem in less time than it takes to watch a movie. The immediate aftermath is utterly brutal, triggering severe radiation poisoning, uncontrollable nausea, internal bleeding, a complete shutdown of the body's natural defenses, and ultimately, a tragic end to the voyage. Engineers try to counter this by building tiny, heavily armored panic rooms inside the ship for astronauts to weather the storm. However, these dense bunkers weigh the vessel down and still cannot block the endless, piercing drizzle of deep space cosmic rays. Bathing in that immense ocean of stellar energy utterly ravages human biology in terrifying ways. The likelihood of abnormal cell growth skyrockets, jumping 20 to 30% above a person's normal baseline. The heart muscle weakens, delicate blood vessels degrade, and vision can permanently cloud over. Even the intricate wiring of our brain and spinal cord faces mysterious, uncharted deterioration. Laboratory tests simulating these harsh cosmic environments on test subjects reveal devastating brain fog, erased memories, and entirely altered personalities. Groundbreaking research even hints that traversing the void literally hits the fast-forward button on our cellular clocks. But do you want to know the most terrifying piece of this cosmic puzzle? We are essentially flying blind because our species has absolutely zero empirical data on surviving an environment this radioactive. Think of the legendary lunar pioneers from the Apollo era, who certainly ventured beyond our planet's protective magnetic bubble. Yet they only stayed outside for about a week. Those living aboard the orbital space station definitely soak up higher doses of energy. Yet they remain safely hugged by Earth's invisible magnetic shield, leaving us with exactly 0 humans who have endured 3 straight years naked in the dark void. We are merely making educated guesses based on laboratory animals, brief orbital excursions, and complex computer simulations. The grim reality waiting out there could easily outpace our darkest calculations. Imagine the stellar energy teaming up with crumbling bones, melting muscles, and a suppressed immune system to invent horrific new biological crises. Our fragile biological vessels simply lack the evolutionary hardware to last 3 continuous years drifting through the cosmos. Billions of years of adaptation specifically tethered us to this blue marble. The hostile void cares nothing for our origins. Every single sunrise, every passing month, and every grueling year away from home actively dismantles our physiology. We can definitely fight back a bit, using intense workout routines, specialized pharmaceuticals, and brilliant strategic planning. Yet we cannot stop the decay entirely, and after a 3-year voyage, that compounding ruin could become permanent. But what happens when we strip away those biological factors? Let us shift our focus to the grueling mechanics of we are exceptionally meaty biological engines, requiring a constant stream of fuel, fresh oxygen to fill our lungs, clean liquids to hydrate our cells, nutritious calories to burn, cozy warmth to prevent freezing, and a reliable way to flush away waste. All services our home world generously provides for free. The churning sky grants us breath, while the massive circulating hydrosphere delivers endless refreshment via storms, rivers, and deep oceans. The vibrant biosphere works tirelessly to sprout bountiful harvests from the soil, and the incredibly complex global climate acts as a massive, invisible thermostat, keeping us perfectly comfortable. Have you ever stopped to consider how effortlessly we breathe? Down here on our blue planet, the very essentials of survival are simply handed to us by Mother Nature. But the moment you step out into the cosmic void, that free ride comes to a sudden, chilling halt. Out there among the stars, each lung full of oxygen has to be meticulously manufactured or endlessly repurposed. A simple sip of water becomes a luxury, demanding that we either haul it across the galaxy or filter it out of our own bodily fluids. Dinner isn't just served, it is carefully vacuum sealed for the journey, or coaxed to grow inside highly controlled synthetic greenhouses. Surviving the extreme freeze and boiling radiation of the cosmos means relying on relentless, power-hungry climate machinery. And garbage? You cannot simply toss it out the window. Every scrap must be broken down, sterilized, and fed back into the loop. When we first hopped over to the moon, or even now as we orbit just above the atmosphere, we treat spaceflight like a camping trip, packing the trunk with everything we need. Those early lunar pioneers literally carried their atmosphere, hydration, and pantries on their backs and in their capsules. Today, the folks aboard the International Space Station enjoy a cosmic delivery service, getting a fresh care package every couple of months. Cargo ships dock regularly, bursting with crisp apples, pure drinking water, shiny new gadgets, and essential hardware. Should a critical component shatter in low Earth orbit, ground control just tosses a spare onto the next rocket up. And if anyone is running low on snacks, a restock is already on the launch pad. Ultimately, our orbiting laboratory remains tightly tethered to its home world. Think of it less as a self-sustaining alien colony and more like a high-altitude suburb, heavily dependent on the mainland's supply lines. However, journeying to the red planet completely shatters that umbilical cord, thrusting us across an unimaginably vast ocean of empty space. Just sending a simple radio transmission across that immense distance takes anywhere from 4 to 24 minutes in a single direction, entirely dictated by where our two worlds are currently racing around the sun. Meaning a live phone call to Houston to troubleshoot a catastrophic failure is simply impossible. Picture this. You hit the panic button, but you will not hear a single word of guidance for 8 to 48 agonizing minutes. When disaster strikes in the lethal vacuum of deep space, every ticking second is a matter of life and death, making a nearly hour-long silence a definitive death sentence. Sending emergency backup supplies? You might as well forget about it, because orbital mechanics just will not allow for a quick rescue. Should our brave explorers drain their final reserves of oxygen or hydration, or if the machinery keeping them alive breaks down, humanity back home is completely powerless to intervene before the clock runs out. An emergency relief vessel would spend an agonizing 6 to 9 months coasting through the solar system just to reach Martian orbit. By then, there would be no one left to rescue. Which brings us to a stark reality. Anyone venturing out that far must carry an entire, unbreakable ecosystem with them. Their pressurized home, the intricate web of survival machinery, and the vital indoor farms. Every single piece of that puzzle has to run flawlessly for years, totally isolated from the rest of human civilization. Building a miniature, infallible Earth inside a tin can represents one of the most monumental technological hurdles in our history. We have already built a masterpiece of survival tech aboard the International Space Station. It works magic with the atmosphere, aggressively scrubbing out the toxic exhaust of human exhalation, and literally zapping liquid water with electricity, ripping the molecules apart into breathable oxygen and volatile hydrogen. That precious, life-giving oxygen gets pumped right back into the modules for the crew to inhale. Meanwhile, the leftover hydrogen is either tossed overboard or smashed together with carbon emissions in a clever chemical dance, the Sabatier process, to magically forge fresh water. This brilliant plumbing reclaims roughly 90% of all moisture aboard, wringing it out of sweaty air, astronaut urine, and dirty wash water, pushing that efficiency closer to absolute perfection. Demands a dizzying leap in technological sophistication and massive, heavy equipment. It is a marvel of low Earth orbit, yet it still springs microscopic, unavoidable leaks. Because it is not a flawless infinite loop, cargo ships must constantly ferry heavy barrels of hydration up from the surface to top off the tanks. Tiny droplets inevitably escape the closed circuit and require steady replenishment from home. Add to that the constant need for tinkering, new filters, and replacement valves, luxuries of a nearby planet that Martian pioneers will never have. Out on the Crimson Dunes, survival demands a practically perfect ecological engine, capturing and reusing nearly 100% of everything the crew breathes and drinks. When a few precious drops do vanish, the astronauts will be forced to hunt for salvation right there on the alien landscape. They will have to mine frozen moisture directly from the rusty dirt, a grueling process that drains enormous amounts of power and adds layers of dangerous complexity. And if keeping the air pure and the cups full sounds tough, figuring out what is for dinner presents a vastly more intimidating frontier. Every single explorer burns through roughly 2,000 to 2,500 calories a day, fueling a demanding life of extraterrestrial survival. Imagine isolating a quartet of explorers on a rust-covered world for 3 entire years. How do you fuel their bodies? We are talking about a jaw-dropping demand of roughly 9 million calories, and simply packing vacuum-sealed snacks will not work indefinitely. While dehydrated space meals can technically survive for 5 to 10 years without spoiling, they demand absolutely pristine, flawless environments to do so. That means keeping the climate perfectly steady, eliminating all moisture, and blocking out dangerous cosmic rays. Out on the Martian dunes, the thermometer violently fluctuates like a broken metronome, and the bombardment of toxic solar energy never stops for a second. To protect our cosmic pantry, we would have to construct massively thick, lead-lined bunkers, which eats up an absurd amount of rocket weight. So, what if we tried becoming interplanetary farmers instead? On paper, this sounds brilliant. Seeds can actually sprout in that toxic alien dust, provided the soil is heavily treated with life-giving fertilizers and rich biological matter. We could mimic the sun using artificial beams, perfectly tuned to the exact colors plants need to thrive. Precious moisture would loop endlessly through the base, pulled from evaporating leaves and filtered from the crew's bathroom breaks. However, cultivating a farm large enough to cheat starvation requires building a colossal industrial complex. Picture a massive, climate-perfected bubble fighting against the deadly vacuum outside. You would have to pump thousands of watts into glowing artificial suns, draining vastly more electricity than simply keeping the astronauts breathing. Then there is the nightmare of blighted harvests, alien mold, unexpected insects, or toxic dirt ruining the menu. We would have to become guardians of immense seed libraries just to stop the crops from succumbing to genetic rot. Plus, this is no hobby for enthusiastic amateurs. At least one brave soul must be an absolute wizard in botany and cosmic agriculture, knowing exactly how to save the day when the leaves turn brown. Yes, scientists floating above Earth have successfully coaxed tiny bites of lettuce and radishes out of the dark, but those were merely cute little science fair projects compared to surviving the real void. Engineering a full-scale, multi-year oasis on another planet is like jumping from a sandbox to building skyscrapers. Because the moment those greenhouses fail, our heroes will slowly fade from starvation. There is absolutely no safety net, and our home world is way too distant to overnight a rescue package. The astronauts either resurrect their dying farm, or they become permanent ghosts in the red dust. Every single piece of technology touching that alien rock has to respect this ruthless truth. You get 0 do-overs, absolutely 0 white knight rescue ships, and not a single crumb of backup supplies from the blue marble. Having a plan B is mandatory. You need a safety net for your safety net, and another one beneath that. Yet, piling on extra gear means creating incredibly heavy and tangled webs of machinery, skyrocketing the price tag while offering new ways for things to shatter. It becomes a terrifying game of engineering roulette, where one misplaced decimal point costs human futures. Now, dare to peek into the terrifying financial black hole behind this dream, which is exactly why the madness of proposing one-way, no-return journeys suddenly begins to sound completely logical. Defying gravity burns oceans of wealth. Just look at the legendary moon missions, which torched through roughly $150 billion in modern money. All that treasure bought humanity precisely 6 triumphant touchdowns on our pale neighbor. An exclusive club of 12 men kicking up gray dust, and a combined total of roughly 75 days of human footprints. Crunch those numbers, and simply existing out there cost an eye-watering $2 billion per explorer every single day. Meanwhile, our shimmering floating laboratory in low orbit has swallowed up around $150 billion to piece together and keep operational over the decades. A monumental bill split across the globe. In exchange for that colossal mountain of cash, we have managed to keep between 3 and 7 human beings permanently hovering up there for over 20 years, averaging a burn rate of $1 billion to $2 billion per astronaut annually. Those figures sound like pure science fiction to the average person, yet they merely cover trips into our planetary shallow end, constantly protected by an invisible web of terrestrial rescue teams. Venturing deep into the cosmic ocean toward the Crimson Desert multiplies that financial burden into the stratosphere. If you want to blast a crew out there and actually bring them back alive, the most optimistic guesses start at $100 billion, while sensible blueprints demand over $500 billion. Private pioneers boast they can magically slash that bill to perhaps $50 billion. But exploring the cosmos remains a profoundly expensive leap into the unknown. Think about it. Sending humans to the red planet right now relies on futuristic tech we simply do not possess yet, like magical machines extracting air from Martian dirt, and ships bouncing back and forth across the void like intergalactic taxis. Plus, lifting all that heavy metal into orbit would need to become absurdly cheap compared to today. But let us play along and pretend SpaceX's wildly optimistic blueprints actually come true. $50 billion is still a staggering mountain of cash. Picture handing over the American Space Agency's total yearly allowance for just one project. Blowing that kind of treasure on a single celestial joyride demands a massive explanation. So, what is the payoff here? Could any space rock or cosmic secret truly be worth $50 to $500 billion? But hold on, because the math shifts completely when we flip the script. Imagine buying a ticket to the stars with no return flight. The price tag instantly plummets. Without the massive burden of carrying gas for the trip home, your rocket slims down from a heavy freight train to a sleek sports car. When you completely remove the fiery, dangerous plunge back through our home planet's atmosphere, the ship's engineering becomes beautifully simple. And if we are building a forever home instead of just popping by for a quick selfie, we can steadily ship cargo packages across the solar system year after year, softening the financial blow. Staying on Mars is basically 5 to 10 times cheaper than trying to come back. A direct, one-way journey would run us anywhere from $10 to $50 billion. Meanwhile, a two-way ticket skyrockets to between $50 and $500 billion. So rather than burning a massive fortune just to bring a single squad home from the dusty plains, that same cash could fund 5 to 10 different teams on a permanent outbound voyage. We are talking about planting the seeds of a sprawling, self-sustaining metropolis that mines alien soil and unlocks the universe's deepest secrets. If we look at this strictly through the lens of a cosmic accountant, packing up for good is the ultimate bargain, maximizing the human footprint on a completely alien world
for the exact same budget. It transforms a brief, hollow PR stunt with a waving flag into the birth of an actual extraterrestrial civilization. This is the critical spark that officially elevates us into a species that thrives across multiple planets. Of course, the immediate pushback is a heavy ethical question. Is it deeply wrong to send people on a suicide mission of sorts? You are essentially demanding that these explorers embrace permanent banishment in the dark void, forcing them to gaze at the pale blue dot one last time, knowing they will never breathe Earth's air again. At first glance, that feels brutal and unforgivable. But look back at our own history, because venturing into the unknown without a safety net is what we do. Think of the ancient master navigators sailing into the vast Pacific Ocean. They pushed their wooden canoes off the sand, fully aware the tides would never bring them back. Consider the brave souls from Europe who crossed the raging Atlantic during the 1500s and 1600s, enduring agonizing months at sea, pouring their life savings into a terrifying gamble where death was a highly likely outcome. The vast majority of those pioneers never set foot on their native soil again. They weren't trapped by invisible walls, but the sheer agonizing expense and overwhelming danger of the trip backward made it completely unfeasible. They kissed their pasts goodbye, abandoning every familiar face and comforting horizon to carve out a fresh destiny in an uncharted wilderness. Countless bodies were swallowed by the ocean or claimed by the harsh new environment. Yet the resilient ones laid the foundations of modern empires. Generations later, those bloodlines blossomed into entirely new cultures across North America and beyond, forging identities entirely divorced from the old world citizens who first set sail. Those ancient oceanic migrations became permanent relocations purely out of severe logistical hurdles. Conquering the rust-colored planet, however, demands permanence because the actual laws of nature enforce it. When you battle gravity and orbital mechanics, clawing your way back out of another world's gravity well is infinitely harder than simply dropping in. So when we gaze up at that glowing red dot and dream of our future, it is time to drop the fantasy that settling the solar system will be anything like our quick weekend getaways to the moon. Have you ever considered that our next cosmic leap isn't about exploring the unknown, but moving in permanently? The trailblazers heading to the red planet won't be your typical space explorers. They will be permanent settlers. They are packing up their lives for good, planting the seeds of human civilization on an entirely new world. Think back to the moon landings. This next giant leap requires a completely different breed of bravery. Those brave lunar heroes rode rockets into the darkness, but they always had a return ticket waiting in their back pocket. These future inhabitants, however, are embracing a one-way trip into the cosmic wilderness, happily trading our lush green forests for rusty plains, fully aware their boots will never touch Earth's soil again. Would you raise your hand for that journey? While 99% of us would pass, a rare few are already packing their mental bags. History has always produced thrill seekers, individuals hungry to write the next chapter of human evolution, who gladly trade a cozy bed for a pressurized pod if it means leaving a massive legacy. Those are the unstoppable dreamers who will conquer the Martian frontier. Let us look at the math. Funding a permanent bedrock makes vastly more financial sense than bankrolling an interplanetary vacation. Imagine dropping billions on a rocket flight just to visit. It makes vastly more sense to fund the trip once to lay down. Heavy-duty architecture built to last for generations, rather than burning even more cash trying to haul everyone back. We are talking about setting up massive, heavy-duty domes rather than dropping off flimsy temporary camping tents. We must ship out giant robotic miners to harvest local ice and rock, alongside heavy industrial machinery,
going way beyond simple magnifying glasses and test tubes. We are essentially dropping off the ultimate starter kit to build a city that can eventually survive entirely on its own. When you factor in the brutal physics of escaping gravity, this one-way ticket is the only strategy that actually adds up. But the true challenge isn't rocket science. It is the incredibly deep, often ignored mental toll of a point of no return voyage. Stepping onto that transport vessel to the Red Planet, knowing there is no turning back, is not merely a shift in your physical zip code. It is an absolute total rewiring of your brain and soul. Picture cutting the invisible threads tying you to everything you have ever known, including your closest friends and relatives, your native customs, and that familiar blue canopy you stared up at as a kid. Even the comforting pull of our planet's gravity is gone forever, making this transition feel, in many ways, like the end of your old life. The Earthling you used to be literally cannot survive in this new paradigm, because the cradle that nurtured you is light years away. To make it out there in the dark, you must undergo a complete metamorphosis. You transform into a creature of the cosmos, one who watches a dusty butterscotch sky and a pale blue sunset without blinking. Your muscles learn to instinctively bounce and glide in 1/3 of the gravity you were born into. Slowly but surely, the bizarre and alien becomes your new definition of normal. Scientists have studied deep freeze outposts in the tundra to guess how our brains handle extreme isolation. The frozen bases of Antarctica give us our best earthly preview of this madness. Those icy crews battle intense loneliness and the crushing weight of utter isolation, trapped in a hostile wasteland. But they possess a secret weapon. They know the freeze will eventually break. They know the ice will melt, and a rescue ship will eventually arrive. That hidden safety net, resting quietly in the back of their minds, keeps them sane when the darkness creeps in. They always have an escape hatch back to regular life. But our interstellar pioneers face an entirely different game. For them, there is no finish line or flight back to reality. The rusty dunes are their permanent backyard now. Our lush, vibrant home world will fade into a glittering myth, kept alive merely through archived videos, glossy digital pictures, and bedtime stories told in the dark. Yet, against all odds, humanity finds a way, because our species is built to survive and thrive anywhere. We easily mold ourselves to harsh frontiers, carve out fresh communities, and discover profound purpose in the void. Fast forward a bit, and this Martian settlement will blossom into an entirely distinct civilization, complete with its own holidays and customs, and a vibe totally disconnected from Earth. Within a couple of decades, native-born space kids will claim the crater as their only true turf. Before we know it, they will look up at the night sky pointing at a tiny blue dot, wondering what life was like in that bizarre mythical land their ancestors once called home. Imagine stepping off a spacecraft onto an alien world, knowing you will never feel the breeze of your home planet again. Those initial years are going to be a massive shock to the system. Your mind might still be anchored to the pale blue dot, but your body is trapped millions of miles away, across an unforgiving void. Deep feelings of despair, overwhelming dread, and intense friction between crewmates. Every single mental hurdle faced by confined crews on Earth will multiply exponentially when the return ticket doesn't exist. You cannot simply throw in the towel, pack your bags, or walk out the front door. Making peace with your neighbors becomes a literal matter of survival, because banishing someone from the habitat essentially means handing them a death sentence. Space agencies will undoubtedly have to put applicants through an absolute gauntlet of psychological stress tests to find the most unbreakable minds. Yet they must still brace for the harsh truth that human brains can and will shatter under alien skies. Picture the terrifying scenario where an explorer completely loses their grip on reality while standing in the Martian dust. What do we do when a pioneer wakes up one morning paralyzed by regret,
begging to be taken back. Imagine looking them in the eye and explaining that the world they remember is permanently out of reach. These are not just fun philosophical thought experiments. These crises are inevitable, meaning any off-world settlement must be engineered with deep safety nets right from day one. We are talking about robust counseling frameworks, dedicated mental health facilities, and an entirely new culture built specifically to carry the crushing, eternal weight of planetary banishment. Look back at that controversial Mars One initiative, a program that infamously pitched a direct, non-return journey to the Red Planet. When they opened their doors for sign-ups, they were flooded with over 200,000 eager submissions. Let that sink in for a moment. 200,000 human beings willingly offered to say a final, irreversible goodbye to everything they ever knew. Yes, that specific enterprise ultimately turned out to be a hollow pipe dream that crumbled before a single engine ignited. However, the sheer volume of those eager candidates tells a profound story. It proves beyond a shadow of a doubt that a huge demographic is incredibly eager to embrace the ultimate frontier. There are countless individuals who gaze up at the night sky and find the brutal, freezing deserts of our celestial neighbor far more intoxicating than the comforts of our own world. Their driving forces were beautifully chaotic. Some craved the ultimate adrenaline rush, others were driven by an insatiable thirst for discovery. And many simply felt like aliens on their own planet, desperately hungering for a blank slate across the cosmos. Countless others just desperately wanted their names carved into the eternal bedrock of human history. Whatever the spark, the fire inside them was genuine, and it gives us a clear picture of who will actually build our first extraterrestrial cities. It certainly will not be the average person, but rather a hyper-specific breed of visionary who has fully embraced the concept of absolute detachment. Ironically enough, slamming the door shut on any possibility of coming back might actually be the secret to surviving the mental transition. By burning the ships, you destroy the crippling illusion of a rescue, erasing that agonizing ache for a home you can never touch again. From the moment your boots hit the regolith, you recognize that this barren rock is your entire universe now, pouring every ounce of your soul into keeping it alive. You won't waste precious decades staring into the blackness, obsessing over a fantasy extraction date that is nothing more than an empty promise. Instead, you go all in on surviving your new alien reality. But shifting gears, there is a fascinating hidden danger in space exploration called the progress paradox. Roughly every 26 months, orbital mechanics gift us a brief, perfect trajectory between Earth and Mars. Meanwhile, human innovation never sleeps. With every passing year, our propulsion systems grow dramatically more powerful. Artificial atmosphere generators get vastly more dependable, and our ability to manufacture fuel from alien dirt inches closer to perfection. So, if you are an engineer tasked with mapping out a two-way journey, you are instantly paralyzed by a brutal dilemma. Do you light the candle right now using the tools you have? Or do you hold off for 26 months to launch with significantly more advanced hardware? The tricky part is, once that next planetary alignment finally rolls around, you are right back at square one. Why fly today when just another 26 months promises a revolutionary breakthrough? Postponing the voyage always looks like the smartest play on paper, since tomorrow's spacecraft will inherently be vastly superior, vastly cheaper, and vastly safer than today's. Yet, this endless pursuit of perfection creates a toxic loop that constantly pushes the horizon further away. After all, how can anyone justify risking the lives of astronauts on outdated tech when waiting a mere couple of years drastically shifts the odds in their favor? The tragic punchline, of course, is that waiting for the perfect moment guarantees you will never leave the launch pad. We end up burning through entire generations drafting beautiful blueprints and testing engines, yet we never actually leave our footprints on another world. Have you ever wondered why our cosmic footprints suddenly stopped decades ago?
That is exactly the trap we have been stuck in since the final Apollo missions. The schematics are meticulously drawn up and ready to go. We have built the hardware, yet we constantly hesitate, paralyzed by the endless pursuit of flawlessly safe technology before we dare to launch. As long as we insist on bringing every single explorer back home, this endless cycle of delay is never going to stop. The absolute threshold for keeping a crew completely secure and ensuring zero failure demands futuristic innovations that simply do not exist in our reality yet. And picture this. By the time those magical breakthroughs finally happen, even shinier upgrades will appear on the horizon, promising even better protection, keeping humanity forever waiting on the launch pad. But what if we change the rules and make it a one-way voyage? Suddenly, the math shifts entirely. The goal transforms from staging a miraculous return flight to planting the seeds of a brand new permanent human outpost. Instead of asking if we can guarantee a totally secure voyage back and forth, we simply ask if our pioneers can endure and build a thriving life out there in the alien dust. It remains an incredible hurdle, yes, but it is a challenge we can actually conquer, using the tools we have today or will invent tomorrow. We already possess the intricate breathing machines and water recyclers needed to keep a crew alive for years. We know exactly how to construct deep space shelters that block out deadly cosmic rays while feeling like a real home. Brilliant scientists are actively testing gear that harvests fuel and air directly from alien soil. Within 10 years, the very machines required to drop humans safely onto the Martian surface and keep their hearts beating will be fully realized. Sure, it will not be completely flawless or devoid of danger, but it provides everything required to spark a new civilization. When we view this journey as claiming a new frontier, rather than just a quick scientific detour, everything changes entirely. Pioneers heading out into the dark naturally embrace steeper dangers than your average astronaut, because their ultimate reward is an eternal legacy. They are laying the foundation for an entirely new branch of humanity, not merely picking up a few space rocks. Since nobody is planning a return trip, the agonizing pressure to craft an absolutely flawless spacecraft simply vanishes. Think of it like a growing cosmic village, where later rockets constantly deliver upgraded tools, fresh supplies, and new experts. It becomes a steady, expanding flow of life across the void, rather than one terrifying all-or-nothing slingshot ride. Embracing this bold mindset is the only real chance we have of watching humans walk on another planet before we die. Holding our breath for a perfectly safe two-way ticket ensures we will be stuck on Earth until the end of time. Realizing that those initial, brave souls will never come home is the true key to unlocking the Martian frontier right this very second. Using the exact technology in our hands and the funding we actually possess. Now, let us dive deeper into the raw physics and human biology governing this vast cosmic ocean. Imagine a human body adrift in space or wandering Mars for 3 years. The physical alterations are so severe that feeling Earth's gravity again might become a biological impossibility due to bone decay, extreme muscle wasting, severe heart modifications, and relentless cosmic radiation bombardment. Like rust slowly devouring iron, these cosmic forces multiply endlessly with every passing day. Eventually, you hit an invisible biological wall, a tragic line in the sand, where an explorer becomes so deeply tuned to the gentle pull of a lighter world that our heavy home planet would literally crush them. Where does that invisible boundary lie? It remains one of the greatest mysteries of the universe, simply because nobody has ever stayed out there long enough to find out. The ultimate record for floating in the void belongs to Russian cosmonaut Valery Polyakov, who spent 437 days aboard the Mir orbital laboratory. He miraculously made it back, enduring brutal physical therapy to stand again. Yet those 437 days only amount to roughly 15 months. A full Martian campaign demands 3 years, stretching out to more than double that grueling record. The physiological toll of such an immense journey could warp the human frame in ways we cannot even fully imagine. And what about the very first children born beneath the red sky? Should our new civilization reach that incredible milestone, those native Martians could never dream of surviving a visit to the pale blue dot. A baby raised under a gentle 38% gravitational pull would forge a delicate skeleton and muscles designed entirely for the red planet, making our heavy Earth completely lethal. Think of their hearts acting like gentle pumps, perfectly tuned to push blood around in a world where gravity barely pulls back. From head to toe, their internal wiring would belong entirely to the red planet, severing biological ties with our home world. Imagine them taking a vacation back to Earth. Our normal atmospheric pressure would feel like an invisible elephant sitting on their chests. Simply standing up could cause their delicate, bird-like skeletal structures to splinter beneath their own mass. And that gentle Martian heartbeat? It would wildly struggle to push oxygen up to their brains against the relentless downward drag of our planet. Merely stepping off the spaceship could prove fatal within a matter of hours. Should this new branch of humanity take root, they would forever remain isolated from us terrestrial beings. We would be looking at two distinct branches of people, forever separated by an invisible gravitational wall. While this might sound like a wildly imaginative plot from a classic sci-fi movie, it is actually just basic, inescapable biology. Nature always finds a way to mold living organisms to perfectly fit their surroundings. Spend your whole life floating through 38% of our normal gravity, and your physical form will literally rebuild itself for that exact environment. To these future descendants, the lush green hills of Earth would seem just as terrifying and hostile as the freezing Martian deserts appear to us today. This creates a massive roadblock for anyone dreaming of coming home. Even if we somehow figure out how to make round-trip rockets cheap and easy to build, or if we master the art of manufacturing endless rocket fuel straight from the alien dirt, the human body itself will throw up a giant biological stop sign, permanently blocking that voyage back. Those brave initial pioneers could undergo physical transformations so intense that Earth's atmosphere becomes a literal death trap for them. Suddenly, their grand expedition transforms into an absolute point of no return. And this isn't because the spacecraft broke down, or because they chose to stay, but simply because Mother Nature demands it. Their own anatomy locks the door and throws away the key. Yet, in the grand cosmic scheme, maybe that is exactly how it is supposed to work. After all, the very essence of evolution is rewriting our biological code to survive whatever the universe throws at us. We hominids grew up on this pale blue dot, fine-tuning our cells to match its exact temperatures and pressures over millions of sunrises. If humanity truly wants to leap among the stars and call multiple worlds home, we must accept that our bodies will have to morph to fit those alien landscapes. Those courageous souls who settle the rust-colored dunes, provided their fragile outposts endure the test of time, will slowly drift away from the classic human blueprint. We wouldn't be talking about an entirely new species, at least not until thousands of generations have passed. Yet they would undeniably become a unique breed of people possessing bizarre and fascinating physical traits. Picture them towering over us, their spines stretching out like unfurling accordions because there is hardly any downward force squishing their vertebrae together. Imagine completely different muscle shapes, perfectly sculpted for taking long, bounding leaps instead of heavy, trudging steps. Picture altered blood vessels and honeycombed, feather-light bones developing gradually as the centuries tick by. Given enough deep time, we would witness a crystal-clear fork in the human evolutionary tree. That is the ultimate truth of settling the cosmos. You do not just pack your bags and move. You literally allow the new world to reshape who you are. The original wave of star sailors will merely be tourists from Earth, fighting tooth and nail just to stay alive in a harsh, freezing desert. But the babies born under those pink skies will be true children of the dust, knowing our blue oceans only as bedtime fairy tales. By the third generation, they will be creatures of the red planet through and through, forged entirely by its unique rules, loving that barren rock as deeply as we love our forests. But this brings up a massive, uncomfortable question we desperately need to tackle. Can we in good conscience launch brave explorers into the dark void, knowing they can never, ever return? Does our morality allow us to hand someone a one-way ticket to eternal banishment? And how do we honestly defend burning through billions upon billions of dollars to build fancy domed cities millions of miles away while our own home planet is practically crying out for help? Make no mistake, these are incredibly heavy dilemmas, and you will not find a quick or easy answer wrapped in a neat little bow. Whether you think this cosmic leap is right or wrong completely hinges on the lens through which you view our journey into the unknown. If you look up at the rockets and see nothing but an arrogant playground for billionaires and ultra-rich superpowers, then absolutely not. Dumping mountains of cash into Martian real estate feels utterly criminal, while so many of our fellow humans down here are battling severe hunger, devastating plagues, and struggling just to find clean drinking water. However, what if you flip the script and view this monumental effort as the ultimate life insurance policy? If spreading to the stars is the only way to safeguard the flame of human consciousness from world-ending asteroid strikes or planetary collapse, suddenly the math of our destiny looks profoundly different. Have you ever wondered what happens when our blue oasis runs out of luck? Our homeworld is currently staring down some very real existential threats. Sure, a rogue space rock slamming into us is not an everyday event, but the cosmos is a shooting gallery, and a direct hit on a crowded continent would wipe it off the map instantly. Then you have the monsters sleeping right under our feet. Massive volcanic blowouts could choke the skies and plunge us into sudden, freezing winters. Add to that our own dangerous inventions. As long as doomsday arsenals sit in silos, the shadow of atomic fire hangs over our heads. We are also at the mercy of microscopic invaders, invisible plagues with the power to sweep through populations like wildfire, claiming countless lives. Right now, our weather patterns are spiraling out of control, violently shifting environments and forcing entire communities to flee their homes. We are essentially pushing our fragile ecosystems to a breaking point, threatening to turn lush regions into barren wastelands. But let us zoom out for a moment and look at the grand cosmic clock. Deep time reveals absolute certainties. Our local star, like a glowing ember, is getting hotter and brighter as it burns through its twilight years. Fast forward roughly 1 billion years, and this gentle blue marble will be scorched, boiling away every drop of water and extinguishing all biology. Give it 5 billion years, and that same star will swell into a massive, angry red giant, literally swallowing our planet whole. To a human mind, those timelines sound like forever away. Yet in the grand cosmic theater, they are absolute guarantees. Our world comes with a cosmic sell-by date, which means if we keep all our eggs in this one planetary basket, our species will expire right along with it. Building fully independent outposts scattered across the dark ocean of space is our only ticket to outliving the very cradle that birthed us. Now, let us be clear. The red planet is not a magical lifeboat for 8 billion people. Even a thriving Martian city would likely max out at just a few thousand, maybe tens of thousands of pioneers for generations, if not centuries to come. So, packing up for the dusty rust world will not magically fix the messes we have made down here. It is not an evacuation plan for the general public, but rather a cosmic hard drive, a planetary backup file, a secure off-site server where the spark of human culture and knowledge stays lit, even if our home world goes dark. When you look at it that way, writing the check for a Martian settlement is simply paying the premium on a species-wide life insurance policy.
So is securing our legacy worth $50 billion? Or even $100 billion?
A lot of visionaries would say that is a bargain. Think about it. Nations routinely pour staggering mountains of cash into weapons and defenses for hypothetical wars that might never actually happen. Shaving off just a tiny sliver of the world's wealth to plant our flag on an alien world feels like a brilliantly sound investment for ensuring we have a tomorrow. But what about the moral dilemma of asking explorers to walk away from their home planet forever? That is a deeply complex puzzle. On one hand, humanity has always asked its bravest to walk into the unknown. Just like troops stepping onto a battlefield, or daring aviators strapping into untested rockets, or mountaineers challenging the deadly peaks of the Himalayas. Throughout history, we have celebrated those willing to gamble everything for a calling greater than themselves. So if a pioneer stares down the brutal reality of a one-way ticket to a barren wasteland and still raises their hand, do we really have the moral authority to stop them? These are fully grown individuals, charting the course of their own destiny with their eyes wide open. The absolute foundation here is complete transparency and willing agreement. Every potential voyager needs to truly grasp the monumental sacrifice they are making. We are not just talking about rockets blowing up, but the profound, crushing isolation of never seeing a blue sky again. The bizarre ways low gravity will wither their bones, and the grim reality that existing on a frozen desert will be infinitely more brutal and likely much shorter than living on Earth. Above all, they must embrace the chilling truth. Out there in the void, there is no safety net, and no rescue ship is coming to save them. If they absorb that terrifying picture and still choose to strap in, then letting them launch is the ultimate respect for their personal freedom and their burning desire to carve their names into the grandest milestone in human history. Doing otherwise is simply treating adults like children, arrogantly assuming we know what is best for their own souls. For certain extraordinary minds, the ultimate equation will balance out, becoming the foundational bedrock of a new alien civilization, pushing the boundaries of where our species can thrive among the stars. For these pioneers, trading their earthly home for a permanent place in cosmic history is a price they are willing to pay. And honestly, who are we to judge that kind of ultimate dedication? Let us be real here. The harsh Martian environment will claim lives, perhaps even the majority of those early explorers. Yet we must honor the profound sacrifice of those who dare to go. So let us step back and look at the whole picture. We have explored the massive void of interplanetary space and the celestial dance of orbital mechanics that traps anyone on the red planet for 2 whole years, just waiting for the planets to align for a journey back. We have talked about the monumental headache of carrying enough propellant, diving into the relentless math of the rocket equation, where bringing a ship home demands a staggering exponential mountain of extra resources compared to dropping it off on another world. We have also investigated manufacturing our own rocket fuel out of the Martian dirt, a brilliant theoretical fix, yet one that is absolutely packed with terrifying uncertainties and engineering gambles. We have looked deeply at the horrific toll this alien environment takes on flesh and blood. From skeletons crumbling like chalk in low gravity, to cosmic radiation baking the crew over 3 years, causing cellular damage that simply cannot be undone. We have examined the razor-thin margin of error for survival, where habitats must recycle every drop of sweat and breath of air with absolute perfection, millions of miles away from any earthly rescue ship. We have faced the cold, hard cash problem, acknowledging that sending a crew on a one-way ticket costs 5 to 10 times less than trying to bring them safely home. We have delved into the dark mental labyrinth of forever leaving the blue marble behind, and the unique mindset required for those exceptional souls who would volunteer to become the very first Martians. We have navigated the illusion of the perfect launch date, proving that if we wait around for futuristic warp drives, humanity will forever remain grounded. And finally, we have confronted the chilling biological truth that a human frame, once perfectly remolded by the gentle pull of Martian gravity, would be instantly crushed by earthly gravity even if we built a magic ship to bring them back. Every single one of these cosmic roadblocks points to a singular, undeniable conclusion. The inaugural voyages to our neighboring world will be permanent relocations. This is not out of malice or because space agencies lack empathy, but simply because the fundamental laws of the universe, the limits of the human body, and the staggering financial costs dictate that a permanent settlement is possible, while a round-trip vacation is a logistical nightmare. Of course, this does not mean the door is closed forever. Human innovation never sleeps. Perhaps 50 or 100 years from now, engineers will conquer the vast oceans of space with exotic engines that turn the fuel crisis into a footnote of history. Perhaps medical science will unravel the mysteries of cellular decay and microgravity, creating biological shields against muscle melting and bone loss. Perhaps one day, there will be bustling interplanetary highways, with massive space liners ferrying generations of humans and goods seamlessly between two thriving worlds. But that is a sci-fi dream belonging to an era yet unborn. Assuming we even make it that far. The reality for our generation is stark. The original explorers who step foot on the rust-colored dirt will breathe their last breath there. And in a strange, poetic way, perhaps that is exactly how it should be. Think back through the shadows of time. The earliest voyagers always burned their boats when charting the unknown. They sailed across violent seas and marched into untamed wildernesses, facing brutal conditions that erased entire expeditions from existence. But the resilient few who weathered the storm planted the seeds of entirely new civilizations. Their ultimate sacrifices, their unyielding bravery against the dark, and their profound willingness to sever ties with the familiar, paved the way for the vibrant, interconnected society we know today. So, how exactly do we bridge the gap from Earth to the stars? Let us dive into the actual blueprint of this cosmic leap, because visualizing these gritty details transforms the idea from a dream into an impending reality. The grand endeavor would kick off not with a human crew, but an armada of robotic freight ships. Several automated spacecraft would blast off into the void, across multiple planetary alignments, long before our astronauts even suit up on the launch pad. These preliminary drops are the lifeblood of the mission, gently landing the very shelters and artificial biospheres that will keep the future colonists breathing. Have you ever wondered what it takes to build a second home for humanity? It all begins with robots, machines sent ahead to mine the dirt for fuel, alongside sprawling solar arrays and massive nuclear generators. Then comes the cosmic lifeline, stockpiles of food, cutting-edge medical bays, and the essential tools, plus mountains of spare parts to keep the dream alive. This sprawling robotic construction phase alone could easily consume 4 to 6 years, demanding 2 to 3 separate launch windows just to hurl roughly 80 to 100 tons of gear onto the rust-colored soil. Picture a fleet of automated cargo ships, each spending 6 to 9 months coasting through the blackness of space before touching down to spend months, or even years, completely alone on an alien world. Like a ghost town coming to life, they would autonomously unpack modules, power up life support, and fire up those vital fuel refineries. By the time our brave astronauts finally strap into their rockets, a fully functional high-tech village should, fingers crossed, be waiting for them. Imagine inflatable domes already pressurized with breathable air, glowing with reliable power, and propellant tanks brimming with rocket fuel for their eventual return trip. But here is the terrifying catch. These explorers will launch knowing their very existence hangs on machines that have been baking in Martian radiation for years, totally unchecked by human hands. If a single crucial valve broke 1,000,000 miles away, they are essentially riding a rocket straight to their doom. And the haunting part? They will not know for absolute sure until their boots hit the dust. Just getting there is a psychological nightmare. Imagine being locked inside a spacecraft no bigger than a typical camper van for 6 to 9 months. You are stuck with a crew of 4 to 6 people, the absolute bare minimum needed to fly the ship and fix things, all crammed together in a space smaller than your living room. Every single inch of real estate is priceless, packed to the ceiling with rations, science experiments, and flight controls. Personal privacy? That concept completely vanishes the moment you leave Earth's orbit. You will stare at the exact same expressions, listen to the identical voices, and breathe in the very same recycled smells, hour after hour, for the better part of a year. Think about the science of human endurance. Studies from deep-sea submarines and frozen Antarctic outposts tell us a harsh truth. Even the calmest, most balanced individuals crack under the intense pressure of endless isolation with a tiny group. Suddenly, the smallest spark can trigger an explosive argument. The way a crewmate chews their freeze-dried food might make you want to scream. A simple habit of clearing their throat could slowly drive you insane. Tiny quirks mutate into giant psychological monsters purely because there is absolutely no backdoor. You cannot just walk away and take a deep breath. Down here on our blue marble, if you clash with a friend, you grab your coat, step outside, feel the breeze, and clear your head. Out in the void of interplanetary space, stepping outside means instant death. Your entire universe shrinks to a handful of metal tubes, and your only companions are always right there. Space agencies will fiercely test these astronauts for mental toughness, but they can only manage the boiling pot. They cannot turn off the heat. To survive each other, they will rely on rigid rules for settling disputes, tiny scheduled pockets of alone time, and rotating shifts designed to break up the monotonous routine, giving everyone a brief mental break from the exact same social circle. And the wild part? They have to endure this social pressure cooker for 6 to 9 months, fully aware it is only the warm-up act. Because the true trial by fire begins the second they plunge toward the Martian dirt. Touching down on the red planet is arguably one of the hardest things in the universe to do. Think of it like a cosmic trap. The air is just thick enough to ignite the ship into a blazing fireball, demanding heavy heat shields. Yet it is way too thin to let a parachute softly glide you down to safety. To stick the landing, you need a flawless, choreographed dance of fiery heat shields, supersonic parachutes, and violently firing retro rockets. And even when it all works, those final seconds are pure, heart-stopping terror. Remember the stunning mission that dropped the Curiosity rover? It literally required a hovering, rocket-powered jetpack to lower a car-sized robot on metal cables just to survive the final drop to the alien surface. It was a monumental triumph for robotics. Yet the brilliant minds who built the machine famously dubbed that fiery plunge the 7 minutes of terror. Picture a perfectly choreographed cosmic ballet where absolutely no human can step in to help, simply because the vast radio lag means our blue planet remains entirely in the dark about the outcome until 14 long minutes have ticked by. Now imagine putting human beings inside that falling capsule. The stakes skyrocket astronomically. We are talking about a significantly bulkier spacecraft, demanding massive amounts of fuel just to brake against gravity's relentless pull. Inside, the astronauts wouldn't be blissfully asleep. They'd be wide awake, feeling every violent shudder, acutely aware that their very survival hinges on heat shields and thrusters performing an immaculate dance at speeds faster than sound. A single glitch? That is an immediate, catastrophic end. A fractured thermal barrier turns the ship into a meteor, while a jammed canopy sends them plummeting into the alien dirt like a stone. Should the braking engines sputter out, it is game over. No magical reset buttons exist out here in the void. The moment that capsule touches the Martian sky, you are locked into a binary fate. Touchdown safely, or perish trying. Let us say they actually survive the drop. Their next agonizing challenge is inspecting the robotic outposts sent years ahead of time. Did their future homes withstand the brutal, freezing solitude of deep space? Is the atmosphere inside still breathable? Or did tiny space rocks tear invisible holes through the hull? Are the breathing machines humming along? Or did a vital gear silently give out? Does the base have electricity? Or have raging red storms buried the energy grids under impenetrable dirt? What about the liquid of life and the emergency rations? Did the plumbing freeze up? Or did the pantry spoil? Each and every single mechanism keeping the Grim Reaper at bay must be rigorously tested. Should a fatal flaw be discovered, these pioneers face a brutal race against the clock to patch it up. Their descent module only holds a tiny fraction of what they need, barely offering enough oxygen and calories to keep them breathing for a couple of lonely weeks. Fail to jumpstart the primary base before those reserves run dry, and the Martian sands become their tomb. There is no cosmic cavalry coming to save them, especially since Houston is still staring at a delayed telemetry screen. Long before Mission Control even gets the signal that they have arrived and hit a snag, crucial hours have already vanished. And while the smartest minds back home scramble to draft a brilliant rescue blueprint, the hands on the clock just keep relentlessly ticking away. Ultimately, life or death choices fall squarely on the shoulders of the explorers, forced to use whatever scraps they can find in the dust. Here is the raw, terrifying reality of a permanent voyage into the unknown. Any tiny hiccup could be your last breath, forcing you to engineer a fix out of sheer willpower and spare parts. You certainly cannot hail an interplanetary delivery truck for a new valve. Hopping on a quick video call with a brilliant engineer millions of miles away is physically impossible. Fleeing back to the safety of our blue marble when things get tough simply is not an option. It boils down to a primal ultimatum. Fix it yourself, or fade into the void. Naturally, this demands a radically unique breed of pioneer. Forget the hyper-focused academics. Humanity needs jack-of-all-trades mavericks who can mentally juggle engineering, medicine, and survival mechanics on the fly. We do not need rule-book-following robots, but rather quick-thinking visionaries who can stare an alien catastrophe in the face and invent a way out. Those accustomed to massive teams holding their hands from afar will not survive. We require lone wolves who embrace absolute independence and aren't paralyzed by the shadow of extreme danger. Picking these interplanetary settlers would look absolutely nothing like the way we recruit personnel for the International Space Station. Orbital scientists are historically chosen for their pristine technical mastery, their flawless execution of checklists, and their talent for thriving inside a rigidly managed, Earth-reliant safety net. They are essentially brilliant executors, carrying out commands piped up from Mission Control to the letter. But those destined for the Red Planet? They must be drafted for their relentless mental flexibility and their uncanny ability to forge pure genius when the cosmos turns against them. Have you ever wondered what it takes to actually survive on another world? It requires unparalleled mental toughness and the fierce drive to stand completely on your own 2 feet. These brave souls wouldn't be your typical button-pushing space explorers. Think of them as the rugged pioneers of the cosmic Wild West. They would need to figure out complex disasters with zero help from Mission Control, making high-stakes gambles when their backs are against the wall. Imagine waking up every single day, knowing the environment wants you gone, and holding on to that ironclad sanity not just for a handful of days, but for countless orbits around the sun, or perhaps until their very last breath. The day-to-day grind on the Red Planet would be utterly brutal, in a way that those of us safely tucked under Earth's cozy blue blanket can barely even fathom. Picture your lungs inhaling the exact same oxygen over and over, scrubbed by machines that can never, ever be allowed to shut down. Every sip you take, it is a liquid ghost that has already passed through your crewmate's veins dozens of times, wrung out from old sweat, bathroom waste, and damp exhales, then scrubbed clean to keep the ultimate closed-loop ecosystem flowing. Dinner means choking down whatever fragile crops you managed to coax out of toxic, rust-colored alien dirt, mixed with whatever freeze-dried rations are left, haunted by the fact that a single blighted harvest equals a slow, agonizing famine. You are essentially living inside a blown-up balloon, entirely engulfed by a dead world that actively wants to snuff you out. Step past the airlock bare-skinned, and the universe would claim your life before you could blink. Because the atmospheric pressure is practically a vacuum, the fluids racing through your veins would literally vaporize and bubble over. Simultaneously, the brutal cosmic chill would snap freeze your flesh into solid ice. And even if you magically dodged the freezing and the boiling, the absolute void of breathable air would suffocate you into darkness. This means every single spacewalk, every tiny excursion into the wasteland to fix a solar panel or scoop up some dust, becomes a terrifying roll of the cosmic dice. That bulky spacesuit is your personal, wearable spaceship. If it glitches, the Grim Reaper is only a few heartbeats away. The sheer mental crushing force of walking that tightrope daily is almost impossible to put into words. Back home on our pale blue dot, getting fresh air just means twisting a knob and walking onto the porch. Out in the Martian dunes, leaving the house demands 60 grueling minutes of suiting up, scanning life support dials, obsessively watching your breathing gas meters, locking down massive metal joints, and sitting through agonizingly slow vacuum chamber sequences. Once your boots hit the dust, your brain is screaming that one tiny tear, one broken zipper, or a single blown circuit equals instant doom, forcing you to tiptoe past jagged boulders and overthink every hand gesture. This alien desert never once transforms into a welcoming neighborhood. It remains a ruthless, lethal wasteland that demands absolute, unwavering paranoia. As the calendar pages turn, that invisible anxiety piles up like a mountain, invisible to the naked eye, yet completely shattering to the human spirit. Evolution didn't wire us to stay trapped in fight or flight forever. Our ancestors survived because they could finally chill out around the campfire, drop their spears, and just breathe, without wondering if the very sky was going to murder them. The Red Planet offers 0 campfires. You are never truly out of harm's way, merely hiding behind a fragile wall of wiring and metal that could short out tomorrow. And then there is the human element, the claustrophobic nightmare of living in a tiny bubble, a detail most starry-eyed mission planners gloss right over. Locking up 4 to 6 souls provides just a tiny dash of personality mixing, but it is a small enough pressure cooker that a simple argument over breakfast can completely destroy the mission. There are no mysteries left. You know every habit, every flaw, every breath of your companions. Personal space is a myth. Secrets are non-existent. And running away from that one guy who drives you crazy is physically impossible. Down on Earth, if a coworker gets on your nerves, you just take a different route home. Vent to your friends at the pub, and let a massive sea of strangers wash the annoyance away. Trapped with a handful of people millions of miles away, hiding is not an option. You stare at their faces every single morning, sweat alongside them, and literally trust them to keep your heart beating. Should a genuinely toxic feud ever ignite in that cramped little tin, have you ever wondered what happens when you are millions of miles away from human civilization, locked in a metal tube, and you get into an argument? Out there, no cosmic referee exists. The pioneers simply have to figure it out among themselves. You cannot just hand a bad teammate a pink slip or kick them off the roster, mostly because stepping outside means plunging into a lethal vacuum. Sending someone to a separate wing to cool off is a mathematical impossibility when your entire universe is the size of a tiny submarine, and everybody needs a clear path to the life support dials. This microscopic society is absolutely forced to operate like a flawlessly synchronized celestial ballet, or else the entire outpost dies. Just think about the crushing psychological gravity that puts on keeping the peace. A tiny annoyance like a crewmate breathing too loudly cannot be ignored before it snowballs into a lethal disaster. If two astronauts simply do not vibe, that fiery friction must be extinguished immediately. Picture having to entrust your very survival to a colleague you secretly despise, painting on a flawless professional facade while biting your tongue. Performing that mental gymnastics routine, it is deeply, profoundly tiring. Keeping a permanent lid on your own natural emotional reactions is like trying to hold a giant beach ball underwater forever. You are forced to play the role of an infinitely polite ambassador, even when your blood is absolutely boiling. You have to plaster on a fake smile for the sake of the settlement, when all you really want to do is scream into the void or hide away in your bunk. Looking at scientists trapped in remote, icy Antarctic bases, we see that interpersonal drama actually causes way more mental anguish, easily overshadowing the terrifying reality of sub-zero blizzards or the constant threat of a frozen death. Human beings are incredibly tough creatures, capable of brushing off nightmarish physical surroundings, just as long as their tribe has their back. Yet, put those same resilient humans in a perfectly safe paradise with a toxic friend group, and their minds will completely shatter. Now, imagine exporting that petty high school drama to the Red Planet. It would be a literal waking nightmare. Feuding spacefarers would still need to fix oxygen scrubbers hand in hand, blindly trusting their sworn enemies to keep them from suffocating, all while sleeping mere inches away from one another, suffocating under a thick, invisible blanket of unspoken grudges and hostility. Because of this dark psychological reality, picking the right explorers means looking way beyond sheer mental toughness, diving incredibly deep into how beautifully these minds blend together. We need pioneers who naturally click together like puzzle pieces, who speak each other's emotional language fluently, who can defuse a ticking time bomb of an argument with absolute grace, and who anchor each other during the darkest cosmic storms. But hey, even if we handpick literal saints, friction is inevitable. Our human brains are wonderfully messy, and the way we connect shifts and morphs just like the drifting sands of the Martian dunes. Two best buddies on launch day could easily mutate into bitter rivals after starring in the exact same confined movie for years on end. To survive the void, this cosmic village would require rigorous, built-in emotional safety nets, perhaps embedding undercover therapists disguised as botanists or engineers among the ranks, alongside strict rules of engagement where the survival of the tribe always completely eclipses what any single individual desires. But what happens when we gaze even further down the cosmic timeline? Because if we are actually building a permanent second home out there in the dark, the first generation of true space babies, human infants taking their first breath on an alien world, will inevitably arrive. This unlocks a Pandora's box of mind-bending moral dilemmas and evolutionary mysteries. Picture a newborn growing up on a dusty sphere where the downward pull of the ground is only 38% as strong as what you are feeling right now. Their skeletal structure would weave together like a delicate, lightweight sponge rather than heavy, dense stone. Their physical strength would adapt beautifully for leaping gracefully across craters, not for carrying heavy loads. Even the heart beating in their chest would grow somewhat lazy, never needing to push crimson rivers against a crushing planetary weight. Once they reach full maturity, they would literally be a brand new species of hominid, a true Martian. So, could this child of the cosmos ever visit the blue world of their ancestors? The grim reality is an overwhelming no, because returning to our pale blue dot would feel like stepping into a giant, crushing, invisible press. Simply trying to stand up could cause their fragile framework to violently snap under the relentless pull of our heavy planet. That weak, alien heart would violently struggle, completely failing to push life-giving oxygen to their brain in this dense environment. Every single movement would become a grueling battle against an invisible titan, leaving them utterly drained and practically glued to the floor, along with severe blood pressure crashes, making the journey back home potentially deadly. A Martian heart, used to pumping blood in low gravity, simply couldn't handle the crushing weight of Earth's pull. These pioneers would find themselves imprisoned on the red planet, held captive not by broken rockets, but by their own bones and blood. Which brings us to a massive moral roadblock. Is it right to bring new life into the world, knowing those kids are forever locked to an alien world? They would be permanent castaways, banished from humanity's home world simply because of where they took their first breath. A lot of folks would strongly claim this is completely unethical, arguing we have no right to engineer generations of humans who are biologically chained to a single hostile rock. On the flip side, you could point out that a person's birthplace has always shaped their destiny, making a Martian childhood no different than growing up in the harshest deserts or highest mountains of our own blue marble. After all, none of us get to pick our starting coordinates. We all eventually mold ourselves to fit the world outside our window. It is just an extreme version of a very normal human experience, though it sparks a fascinating question about how we share our cosmic history with the next generation. Picture parenting on a dusty red frontier. Do you tell your little ones about the paradise we left behind? Do you play them footage of crashing waves, towering green trees, and endless azure skies? Or explain that over 7 billion humans live in that faraway oasis? Do you celebrate that rich tapestry of life? Or do you try to sweep the mother planet under the rug, pushing them to see only the rusty soil beneath their boots as their true universe? All to shield their hearts from yearning for a paradise they are physically barred from touching? Either path we choose comes with heavy consequences. Paint too vibrant a picture of our blue planet, and you might raise a generation fueled by bitterness, dreaming of rain and oceans, while feeling robbed of their birthright. But if you erase Earth from their classrooms, you sever their roots, isolating them from thousands of years of human triumph, art, and civilization, birthing an entirely disconnected Martian society, drifting completely blind to its own origin story. Walking that tightrope would be incredibly tricky, with every household likely writing their own rules on how to tell the tale, which could easily fracture the fragile society into rival camps. Then we hit a purely biological speed bump: the DNA pool. Imagine landing just 4 to 6 brave astronauts to start a new world. That tiny handful of genes is nowhere near enough to keep a species thriving century after century. Without fresh DNA, severe inherited diseases would skyrocket in just a couple of family tree branches. To keep the gene pool healthy, this lonely outpost would desperately need a steady stream of fresh arrivals, making them hopelessly dependent on an umbilical cord stretching millions of miles back to Earth. For a Martian civilization to truly stand on its own 2 feet, it would need a vibrant melting pot of at least several hundred individuals to secure a healthy genetic future. That kind of massive crowd completely dwarfs the tiny crews of our early exploratory flights. We are looking at a marathon spanning several decades of non-stop rocket launches, packing ships with hundreds of brave souls ready to buy a one-way ticket into the dark, all to carefully piece together a biologically robust foundation for a brand new branch of humanity. This monumental, unbreakable promise of time and resources is exactly why taming the red planet is such a massive headache. We are not just talking about planting a flag or sending a quick batch of explorers. This is a grand, multi-century relay race that demands rock-solid dedication from governments, bottomless bank accounts, and an endless line of brave volunteers stretching far into the future. If that supply line snaps, or if politicians back home lose interest and cut the cord, or if a financial meltdown grounds the rockets, that fragile city in the stars could perish entirely. A tiny isolated bubble of humanity on Mars simply cannot last forever without Mother Earth holding its hand, constantly delivering fresh DNA to keep them healthy. And they absolutely need the warmth of human culture to stave off the crushing madness of isolation and societal decay. It is only when this fledgling world finally hits that magic population threshold. Have you ever wondered what it would actually take to sever the umbilical cord to our home world? It would demand a sprawling metropolis of thousands of experts wielding massive industrial power, just to even have a fighting chance at surviving alone in the dark. Reaching that level of total independence? That is a dream still hovering many decades in the future, even if absolutely everything goes perfectly. Let us peel back the layers and truly look at the monumental hurdle of mining and building on an alien world. The red planet is a treasure chest, certainly, but unlocking its riches demands heavy machinery that the first pioneers simply will not possess. Think about the frozen water locked away in the rusty dust. To drink it, you need massive diggers, intense thermal melters, and complex filtration plants. The alien dirt is absolutely loaded with raw iron. Yet transforming that dust into usable metal means generating infernos blazing beyond 2,700 degrees Fahrenheit, demanding colossal amounts of power. If you want to build anything intricate, like a tiny microchip, a delicate gear, or life-saving medicine, you are going to need factory networks that take countless years to construct. At the very dawn of this adventure, our cosmic settlers will be entirely tethered to supply drops from home. Every single wrench, every tiny replacement bolt, and every vital machine must cross the void, agonizingly crawling through space for 6 to 9 months. If a crucial gear snaps and the cupboard is bare, your only options are throwing together a fix out of scrap, praying for a miracle, or simply learning to survive without it. That agonizing reality breeds a never-ending psychological tug-of-war between getting the job done and protecting the gear. Just turning a screwdriver shaves off microscopic layers of metal, inching it closer to its death. Every humming engine and spinning turbine is secretly tallying up invisible scars, inevitably ticking down to a catastrophic breakdown. The pioneers will have to treat their machinery with a fanatical level of reverence, treating every activation of a precious device like rationing the last drops of water in an endless desert, and inventing brilliant workarounds that ignore the mother world entirely. However, as the outpost swells and cargo ships drop off heavier manufacturing tools, their native production muscles will slowly begin to flex. It starts with the primitive blacksmithing of the future, hammering out rudimentary wrenches and bolts from the red soil itself, and utilizing three-dimensional printers to spin recycled trash or local bioresins into fresh plastic shells. They will learn to melt the alien sand into crystal-clear glass for viewing ports, telescopes, and test tubes. From there, the magic of advanced creation begins to bloom, soldering circuit boards, blending exotic compounds, and brewing their own vital medicines. Yet, this evolution is a slow burn spanning lifetimes, and even at its peak, the settlement will still be hopelessly tied to Earth's lifelines. For the truly mind-bending technologies, you simply cannot conjure up a quantum processor or an advanced brain scanner out of thin air when you lack a sprawling web of specialized planetary industries. Trying to rival the raw, unstoppable production engine of our home planet is a milestone that could take these cosmic frontiersmen hundreds of years to reach, because they will be relying on our deep space delivery trucks for such an immense span of time. We need to change how we picture these missions. This is planting an outpost, not declaring a new sovereign nation. These brave souls are not writing a declaration of independence to forge an autonomous world. Instead, they are laying the bricks for a distant harbor that will forever beat with the heart of humanity, intimately tied to our society, despite being separated by millions of miles of empty void. You have to picture those freezing, isolated laboratories huddled together in the deep snows of the South Pole, rather than wooden galleons conquering a new world. Those icy bases always have people living inside them, but their very survival hinges on the cargo planes flown by their parent countries. They never pretend to be completely self-reliant, because the brutal, unforgiving environment simply refuses to let them. And for generations to come, our cities among the stars will mirror that exact same fragile, beautiful struggle. Have you ever pictured a permanent human settlement on the red planet that remains forever tethered to our blue marble? The stark reality is that a tiny pioneer society simply cannot survive without a steady lifeline of cargo ships from home. But have you thought about the invisible barrier of cosmic silence? That vast ocean of space warps the daily human experience in ways we rarely appreciate until we look closer. Imagine shining a flashlight toward our planetary neighbor when our orbits perfectly align. It still takes that signal roughly 4 minutes to cross the void. When the sun sits between us, that same beam struggles for nearly 24 minutes to bridge the gap. Picture the frustration of a cosmic echo, where the absolute fastest reply takes anywhere from 8 to 48 minutes. You beam an urgent question into the dark, and the clock ticks for up to 24 minutes just to hit a receiver. Then you sit there while engineers on Earth scratch their heads and type out a fix. Finally, that data packet begins its grueling voyage back, burning another 4 to 24 minutes. A casual chat over coffee here on terra firma stretches into an agonizingly long ordeal across the solar system. We are literally witnessing the death of the instant message as we venture deeper into the cosmos. Forget about hopping on a quick video call to see your family's faces. If the profound isolation of deep space hits you, there is no comforting voice waiting on the other end of a phone line to calm you down. Instead of chatting naturally, you are essentially launching digital care packages into the void, turning modern astronauts into cosmic pen pals waiting for a physical letter to arrive. Now, imagine what happens when a vital machine breaks down. Picture a failing oxygen scrubber, and your only lifeline is a team of experts millions of miles away. You fire off an SOS, endure the agonizing wait for them to diagnose the glitch, and finally receive the repair manual half a day later. In the harsh environment of another world, the crisis has likely evolved entirely by the time the solution lands. Perhaps your crew already patched the leak, or perhaps the breach has escalated into a full-blown catastrophe. The comforting safety net of live tech support simply evaporates in the vacuum of deep space. As a Martian pioneer, absolute independence becomes your ultimate survival tool, forcing you to become a cosmic mechanic who figures things out entirely alone. This invisible barrier completely rewrites how we run space programs. Aboard the International Space Station, ground teams watch telemetry like a hawk, instantly spotting anomalies and pinging the astronauts. But cast your gaze out toward the Martian surface. The screens down in Houston are practically ancient history, lagging behind reality by up to 24 minutes. By the time they hit the alarm, the disaster on the alien world has either already wrecked the base or been safely contained by the pioneers. This shifts the entire burden of survival directly onto the explorers' shoulders. They must become their own mission control, operating with a level of absolute independence that orbital crews could never imagine. We aren't just tweaking the rulebook here. We are tossing the old manual into a black hole and starting fresh. Exploring the solar system requires rewiring the human brain, developing radical new training methods, and inventing entirely new survival procedures. These future trailblazers must embrace the heavy burden of making life or death choices in total isolation, completely abandoning the safety of earthbound permission and owning every triumph or tragic failure. Imagine carrying the immense psychological weight of sheer solitude, knowing that when a catastrophic event strikes, you are entirely on your own for at least an 8 to 48-minute round trip, plus the agonizing hours it takes the brightest minds back home to even formulate a plan. In the merciless arena of planetary exploration, the dust has usually settled, for better or worse, long before the cavalry's message finally arrives. But beyond the realm of rocket science, Have you ever considered the grand experiment of alien politics? We get so caught up in the thrill of thrusters and habitats that we completely overlook who actually makes the laws in the dark. When humanity builds a second home, who exactly wears the crown? At the dawn of the settlement, it will likely mirror an Antarctic outpost, ruled by a strict captain chosen by the people paying the bills. Whether the logo on the rocket belongs to a government agency, an eccentric billionaire, or a global alliance, that single leader will hold absolute power over the air you breathe, the tasks you perform, and the food you eat. Yet, visualize what happens when this metallic outpost blossoms into a sprawling city, welcoming newborn humans and waves of new arrivals. As this extraterrestrial society expands into a vibrant melting pot, the simple rules of a science lab will inevitably collapse into the chaotic beauty of an independent civilization. Ever wonder what happens to your basic human rights when you leave humanity behind? Do you still get to cast a ballot for your home country from millions of miles away? Or are you entirely cut off from the system? Imagine a brawl breaks out inside a Martian habitat. Who exactly plays space cop? And which world's laws even matter out there? Right now, we are staring into a massive legal black hole, simply because humanity has never actually built a permanent neighborhood on another planet before. Back in 1967, the major spacefaring powers agreed to a landmark cosmic rulebook, which strictly forbids any single country from planting a flag and claiming ownership over floating rocks, the red planet included. However, there is a fascinating loophole. Building a habitat is completely legal, leaving us scratching our heads about who actually gets to run the place. Does the country that paid for the rocket ship automatically get to act as the cosmic landlord? Or perhaps we treat it like the icy expanses of Antarctica, shared and managed by the entire globe. Could this brand new society eventually sever ties and declare itself a sovereign alien nation? At first glance, an off-world rebellion sounds like pure science fiction. But give it a few generations, and it starts looking incredibly inevitable. Picture a civilization of true Martians, people born under a dusty pink sky who have never felt the warmth of our yellow sun. To them, Earth is just a pale blue dot, making it completely natural that they would eventually want to rule themselves. Their logic would be pretty bulletproof. Why should politicians sitting comfortably on a totally different planet get to dictate the lives of deep space dwellers? Especially when these pioneers rely on absolutely zero supplies from the home world and battle deadly radiation and toxic soil. Things we simply cannot comprehend. This disconnect is a perfect recipe for a deep space Cold War. Would our earthly leaders actually let them go peacefully? Could this tear the international community apart, with some cheering for Martian freedom while others demand total control? Imagine massive planetary trade wars over precious alien minerals moving across the empty void. Sure, worrying about interplanetary tariffs feels incredibly premature right now, but the blueprints we draw up today will become the absolute foundation of our very first off-world outposts. The legal seeds we plant right now will grow into the societal forests of the red planet for hundreds of years to come. If we simply copy and paste our current national borders into the cosmos, we are essentially exporting our earthly grudges and territorial battles straight to the stars. On the flip side, cutting the cord right from day one means handing them an incredibly difficult survival test without any kind of financial safety net. After all, taxpayers are not going to happily fork over billions of dollars for a massive science project they cannot boss around. And if we force a massive global collaboration, the endless diplomatic red tape might choke out any real progress before the rockets even launch. The brutal truth is that a flawless roadmap simply does not exist. We are stuck navigating a minefield of massive sacrifices and difficult middle grounds. Yet, we cannot dodge the responsibility. The choices we make will permanently dictate the fate of our pioneering cosmic citizens. Which brings us right back to that haunting premise. Why buying a ticket to our neighboring world
is a strictly one-way journey. We have peeled back the layers of this fascinating reality from every possible angle. From a purely mechanical standpoint, hauling enough propellant to escape Martian gravity turns a simple journey into a mathematical nightmare. Then there is our fragile anatomy. Floating in the void for 3 years mutates our cells and wastes away our bones, perhaps permanently. Looking at the bank accounts, skipping the return flight slashes the budget by 5 to 10 times, freeing up mountains of cash to launch massive habitats and send entire communities into the dark. Mentally, asking people to pack up forever acts as the ultimate psychological filter, naturally weeding out everyone except the most hardcore explorers who willingly embrace eternal isolation. And when you look at how the planets align and our current technological pace, the universe is practically begging us to start planting seeds today, instead of twiddling our thumbs until we invent a magical round-trip rocket. Ultimately, mastering the gritty, everyday survival skills of generating power, breathing manufactured air, and mining dead dirt. Running an operation of this magnitude means we have to look at the red planet as a forever home, not just a quick tourist stop. When you factor in the massive social and political hurdles, building a thriving outpost demands absolute dedication. Instead of just planting a flag and packing up to leave, everything points to one inescapable truth. The expeditions that actually manage to secure funding, blast off the launch pad, and reach their target are going to be one-way tickets. We are not just sending curious scouts. We are launching full-blown settlement initiatives. Those brave pioneers will be bidding their homeworld a final, permanent farewell. That is not a lack of vision or drive, but rather a surrender to the harsh laws of physics.